So what is enthalpy? Enthalpy is a thermodynamic quantity equivalent to the total heat content of a system. It is equal to the internal energy of the system plus the product of pressure and volume.
Enthalpy is also an energy-like property or state function. It is a dimension of energy, thus it is measured in joules or ergs. And its value is determined entirely by the temperature, pressure, and composition of that system.
The total amount of energy in both systems remains the same. Temperature is a factor in determining enthalpy. Refrigerants and chemical hand warmers are both real-life examples of enthalpy.
Despite the opposite results they give, both of the reactions obey the law of conservation of energy. When the refrigerant chemicals in the compressor is vaporized, heat is absorbed in an endothermic reaction. In the hand dryer, iron oxidation is an exothermic reaction that releases heat.
So the equation for the change of enthalpy is delta H is equal to the summation of products minus the summation of reactants.
Here we have a clip of the actual calculation process in solving the change of enthalpy represented with variables A, B, and C. Given a simple chemical equation with the variables A, B, and C representing different compounds as A plus B yields to C, and the standard enthalpy values delta H formation. The formula for this equation is as follows. Delta H reaction equals delta H formation C minus delta H formation A plus delta H formation B. Or in other words, the summation of the change of enthalpy of formation of the products minus the summation of the change of enthalpy formation of the reactants. Delta H reaction is equal to delta H formation C minus delta H formation A plus delta H formation B. Delta H reaction is equal to 1 mole times 523 kilojoules per mole minus 1 mole times 433 kilojoules per mole plus 1 mole times negative 256 kilojoules per mole. Because there is 1 mole each of A, B, and C, the standard enthalpy of formation of each reactant and product is multiplied by 1 mole, which eliminates the mole denominator. Delta H reaction is equal to 346 kilojoules. The result is 346 kilojoules, which is the standard enthalpy change of formation for the creation of variable C. The standard enthalpy of formation of a pure element is in its reference form. Thus, its standard enthalpy formation is 0.
So now, we're gonna focus on how to calculate the enthalpy change of reaction. Example number 2.
This is the given reaction. Water plus carbon dioxide yields carbonic acid. And as you can see, the reaction is already balanced. So let's say you're given the change of enthalpy of formation. So H2 is equal to negative 285.83 kg over mole. CO2 is equal to negative 413.82 kg over mole. And carbonic acid is equal to negative 699.65 kg over mole.
In order to find the change of enthalpy reaction, the reaction is the enthalpy change of reaction is denoted by delta H degree of F. Delta H signifies the change in enthalpy. The degree signifies that it's a standard enthalpy change, and lastly, F indicates that the substance formed from its element. Then, it is equal to the sum of enthalpy change formation into the product side minus the sum of enthalpy change on the formation in the reactant side. The product is everything on the right side, which is the carbonic acid, which is negative 699.65. Then the reactants is everything on the left side, and it is water, which is negative 285.83, and then the carbon dioxide, which is negative 413.82. So everything is balanced, and every substance in the reaction is equivalent to a mole. Then multiply it with the number of moles to eject the moles. Then add everything into the reactant sides and subtract it into the product sides. So the answer is equal to negative 699.65 kilojoules minus 699.65 kilojoules, which derives to the change of enthalpy formation of the whole equation is equal to 0 kilojoules.